Hello everyone, my name is Timothy Lee Grant, and today we are going to come back to Leetcoding. Haven't done this in a while, so let's try to hone our skills again. Alright, come here and try to pick a topic. I'm not sure which one I will do. Should we just... or should we just come down here and just randomly pick a medium? Let's kind of just randomly pick a medium. Let's just have some fun. I don't know. So this one, oh, that's a hard. Next permutation. Okay, let's. I don't like that. It has a 42 right there. I don't like that number. Should we try? Let's just try it. Let's see. We already clicked on it. Okay. So, number 32 or 31, next permutation. A permutation of an array of integers is an arrangement of its members into a sequence or linear order. What? Okay. Hold on. Let's read that again. I understand every single word in that sentence. I don't understand that sentence at all. A permutation, okay, is an array of integers. Okay, so a permutation, they're going to give you the definition. What is a permutation? It is an array that contains integers. Is an array of integers is an arrangement of its members that has each element in that array sequenced in a linear order. Well, aren't all arrays sequenced in a linear order? It seems like all integer arrays follow that definition. Okay. Anyways, for example, an array which has 3 elements, 1, 2, and 3. The following are all the permutations of array. 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Okay, so you can take this array and order matters in this situation. So all 3 elements need to be present, but a distinct permutation consists of all 3 elements in that array, all elements present, but in a unique order. Okay. So the next permutation of an array of integers is, all right, so we're about to get a definition right here. What is next permutation, which I am guessing is going to be pretty important because up here it says next permutation. It's the name of the problem. So let's figure out what this definition is. The next permutation of an array of integers is the next lexiconically greater permutation of its integer. Okay. More formally, if all the permutations of the array are sorted in one container according to their lexiconal or lexicographical order, then the next permutation of that array is the permutation that follows it in the sorted container. If such arrangement is not possible, the array must be rearranged as the lowest possible order, i.e., sorted in ascending order. Okay. So I'm not even going to pretend like I understood a single sentence in that paragraph. Let's look at some of the examples and see if we can find what this means. So, for example, the next permutation of 1, 2, 3 is 1, 3, 2. So they swapped these two here. Okay. Similarly, the next permutation of, and I'm not going to look at it. I'm covering. You can't see it on the video, but I'm putting my finger over the this part right here. So I can't see that. I'm going to try to guess what it's going to be. So of 2, 3, 1, what would the 2, 3, 1? 2, 1, 3? 3, 3, 1, 2. Okay. Okay. While the next permutation of 3, 2, 1 is 1, 2, 3 because 3, 2, 1 does not have a lexicographical larger arrangement. Okay, so when the 3 gets to the front and the 2, okay, I think I kind of understand what's going on. Maybe. Okay. It's like you're trying to. They come in ascending order, and now you're trying to flip it around to descending order. Given an array of integers num, find the next permutation of nums. The replacement must be in place and only use constant extra memory. Okay, and this is C++. We are going with Python. All right. Oh, we have examples. Okay. One. Is this the examples that they gave up here? So 3, 2, 1, 3, 2, 1, 1, 1, 5. Oh, okay. So we can have double. We can have double numbers. 1, 1. And it doesn't have to be in like. It doesn't have to be 1, 2, 3, 4, 5. It can be 1, 5 or 1, 10, 1,000, right? Okay. So the next one is you're going to take this 5 and swap it with this 1. Okay. So the way that I'm thinking about it is there has to be some kind of relationship between like this number and this number, right? Like this number is always going to be smaller than this number if it's not touched yet. But if it is touched, it's going to be bigger? Is that... Because what I'm imagining, just trying to talk of any solution I can think of, or any implementation for kind of how I can get this. I can use like 2 pointers to kind of iterate through the list and say, hey, you, are you, or sorry, are you bigger or smaller than this one? And then based off that information, I can determine if it's been flipped or not. And I keep iterating through like boom, boom, boom until I find one that breaks the rule. And then flip that one and then return that array. But I'm still very, very hazy about what's even going on. Like, what's going on here? So, let's look at this one. Like, what does this mean? 2, 3, and 1. 2, 3, and then this 3 and this 2 are swapped. So let me just try to write something. Okay. So we have 1, 2, 3, like this. Next one is going to be, and they tell it to us, 1, 3, 2. So we swapped these last two. Now, somewhere along here, there's going to be 2, 3, 1. But where that is, I'm not quite sure. And then at the end, we are going to get to 3, 2, 1. And how many are in here? I'm not sure. So we have this 1, 2, 3 up here. 1, 2, 3. We have 3, 2. 1, 3, 2. Oh, is this like in? Oh, this actually might be able to unlock this key. Might be in order because I see 1, 2, 3, 1, 3, 2, and then I also see 3, 2, 1. Okay. So 1, 2, 3, 1, 3, 2, 2, 1, 3. Okay, I'm just gonna kind of take it on faith that that's actually what it is. So 2, 1, 3, and then we have 2, 3, 1, which is right here. 2, 3, 1, and then we have 3, 1, 2. Okay. So now I need to figure out what is the pattern in this. One, two, three. This is how it starts. Okay, cool. We figured out how it starts. So we swapped these two, but why? I'm just trying to read this again. The next permutation of an array of integers is the next lexicographically greater permutation. Like, it would be awesome if they used English. Permutation of its integer. More formally. Oh, great, because that part wasn't formal enough. More formally, if all the permutations of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows it in the sorted container. If such a range... Oh! Well, how could I have been so dense? Of course! Oh, man. Okay, well... So... Now, okay, so great. We swapped those two. Now what do we do? Well, this 3 looks like it got swapped, but this 2 also looks like it got swapped. Okay. Is it like... No, it's not. Because I was thinking maybe it's like you shift the array over by 1 and then this 3 goes here, but that's not what happens here. The 3 is not in the front. I was thinking maybe, okay, well, I shift everything over by 1. So that's kind of what happened here, right? Like this 1 went here, this 3 went there, this 2 went up front. But that's not what happened in this one. So it can't be that. Okay. So 2, 1, 3. How on earth did they get this one? 2, 1, 3. 2, 1, 3, 2, 1, 3. maybe I just look at the next one, see if I can find a pattern. So two remains there. So 1 goes here, this 3 goes there. So the 1 and the 3 get swapped. Okay. So okay. Well, we have to come here. Whoops. I've been disappeared. I don't know if you guys can still see that. Come on. Here, and then okay. There we go. I think we're back. Okay. Awesome. I don't know if you guys could see it when I was switching screens. So let's come here and let's go to Copilot. First thing is try to understand what this problem. So obviously we failed. I failed at this problem. I can't even understand this problem. I can't understand anything about this problem. So nope, we failed. Darn. Sorry. Now is the time where I'm going to try to figure out, first off, if I get a hint on the problem, like what it even means. Can I solve it? And if so, okay, then try to move forward from there. So, but I don't see much point in just sitting here and pondering 3 1 2 2 2 1 1 1, right? Like it's not effectively moving forward. So let's put this in here and say I cannot even understand what this question is asking. Can you explain the question in more simple terms without giving me the code solution? Okay. All right. So imagine you have a list of numbers that you are trying to rearrange them to get the next biggest possible order. If no bigger arrangement is possible, you reset the order back to the smallest possible sequence. So I understand this sentence, but I'm still a little bit confused by what does it mean, a bigger arrangement? Like 1, 2, 3. How is 1, 2, 3 bigger or smaller than 3, 2, 1? Does it mean like 123 and 321? Is that what it's kind of saying? Okay. You take the current arrangement of numbers. Hold on, let me check. Like, is that 1, 2, 3? So 123, 132, 213, 231. Oh, maybe that's what it means. And then is it this one, like 115, and then you have 151. Okay, I think that's what it was meaning. So now that we got that, let's try to think if we can figure out how to implement a solution. So, my brain is still telling me that like 2 pointers is has some hope of working here, because I know that I need to be comparing like the 100th place value with the tens place value, but trying to understand like its relationship versus the other numbers in that string. And how do I know that, okay, well, here there's something unique about these two numbers that I know that this is where I need to swap, and I don't care about the other ones. Okay. 123. How would I know? Like, all of these are bigger, 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 right? Like, it's increasing order, okay? This one, I come here, I look here, and I see that these ones are increasing, and then I see that this is decreasing. Okay. So this is where the rule breaks. So I take this number and put it up. I'm not seeing a solution here. Okay, then I look here. Okay, this is where the rule breaks. So I take this number and move it up. This is where the rule breaks. And then I take that number. So it's not the next number. This is where the rule breaks. So I take that number and move it in. So all right, so I can't think of a solution. I cannot think of how to solve this. Let's come here and say maybe can you explain the solution without code? See if I can maybe take its solution and then implement in code. All right, let's walk through the approach step by step without code. To find the next permutation, follow these steps. Find the pivot point. Start scanning from the right end of the list and locate the first position where a number is smaller than the number immediately after it. This tells us the place where an increase is possible. Oh, so first off, we have to go from this side, okay? and something about pivot points, okay? And that once we find that rule that something was broken, we can say, hey, here's a pivot point, okay? So find the swap candidate. Once you've found that pivot point, look rightward and find the smallest number that is greater than the pivot number. This ensures that the new order is the next smallest possible arrangement. Okay. Swap these two numbers. This step makes sure that you move up to the biggest number arrangement while keeping changes minimal. Okay. Number 4, sort or reverse the right side. Since the numbers to the right were previously in descending order, simply flipping them gives the smallest possible arrangement of these numbers, ensuring the solution is correct. If no pivot is found, that means the numbers are already in descending order, the biggest arrangement possible. In this case, simply arrange everything into ascending order to restart. This process ensures we find the next permutation in place without extra memory. Okay, so first step, find pivot. Okay, so how are we going to do that? We loop through, so for I in range of nums. Okay. Do I want to do that or... Okay, so whatever. Huh, I have not touched Python in a really long time, so I am... Can I go like -1? Is that how you do it? So you, like, I want to start here. Is start, stop is at 0, and decreasing order. I think that's how you do it. Okay. So I'm going to go through everything. Where a number is smaller than the number immediately after it. Tells us where to place an increase. The place where an increase is possible. Tells us where it... So, if nums of I is greater than nums of j, and now j is going to be equal to I minus 1, and that means that actually we don't want to end at 0, we want to end at 1, otherwise we're going to get index outside the bounds of the array. Okay, so this is kind of our trigger, right? Like if the current one that I'm looking at is bigger, is that right? Smaller than the number immediately after it. So maybe that actually means we go plus, and then this is 0, and this is -1, so we start at the second index, like here. and then we look, like, is this number bigger? So if this is bigger, no. Okay. Smaller than the number immediately after it. Smaller than, yeah, is smaller. Okay, so I'm saying if this number here, I'm going to start at the second to last index. So if this number is smaller than the number one above it, which is right here, then we found a pivot point. So this is when this triggers. Okay. So then what we do, then we go to step 2. Once you've found that pivot, look rightward and find the smallest number that is greater than the pivot number. Okay, this ensures the new order is the next smallest possible arrangement. So then I say, okay, here I found my pivot, which is right here, and then I look to my right to find the next what? And find the smallest number that is greater than the pivot. Okay. So now I need to loop through again. So maybe like current equals I plus 1. I can call that J, but I'm just doing that like this. And then say while current is less than length of nums. Okay, something here. And then our lowest equals, this is like the lowest integer that I've found so far that fits that, that fits it. I don't even know what I'm talking about anymore. So lowest is going to be whatever, I don't know, nums of current lowest index is going to be equal to current. Okay, and then I'm going to come here and then see if so I'm going to go if nums of current is smaller than lowest and nums of current is greater than this one with the I, right? I is my pivot. So nums of I, then I replace that. I say, hey, I found a new lowest. So lowest equals nums of current lowest in index equals current, and then current plus equals 1. So I loop through everything. Okay, so now at this stage here, I found my trigger, and at this stage I found my pivot, and the next number to swap, I think. Okay. Okay. Swap these two numbers. This makes sure that you move up the next biggest arrangement. Okay. So sort. Okay, so I can swap. I know how to swap. Alright, so temp equals nums of what do I want to replace? Of I, right? I is the pivot. Okay. Okay. So now I want to put nums of I is equal to nums of lowest index. Okay. And then nums of lowest index is equal to temp. Okay. Then at that point, can I return, because I already found it and I already swapped them. Okay. But we still have step 4. Sort or reverse the right side. Since the numbers to the right were previously in descending order, simply flip them. Flipping them gives the smallest possible arrangement. Okay, so you want to hear something funny? What happens if I just ignore this? You think it will cause me to get the problem wrong? I bet it will, but I don't understand what this is saying at all. So I'm just gonna ignore it and then be pleasantly surprised if it works. There's like I'm gonna give it a 5% chance that it works if I ignore this. Okay, anyways, we need to go to the condition where I looped through everything and I didn't find anything that hit this condition. Right here. So now, if we didn't return, what goes on? Well, I just need to have everything reset it. There is no pivot point. We need to go back to the original. So nums dot sorted. I don't know, sorted or sort. I don't know. Anyways, let's just press run. See if it even compiles. No, it doesn't even compile. Range. Zero. Okay. It doesn't like this. Why? Okay. Syntax error in range. Should be the ending. 0 should be the ending point. But range stops before reaching this value. Stops at 1. Okay. -1. Oh, because the stop is not included or something? Length of nums. What? That didn't make sense. What if I wanted it to stop at positive one? I don't know. Whatever. Separate the argument with commas, not colons. Oh. Okay. So run it again. See if we even get a syntax error. But I have, as I said, a 95% confidence that this is not going to work. Index outside the bounds of the array. Dang it. What? I mean, that makes sense, because I'm not shocked that I got an index error. That is fairly common for me to do, but okay. Because I start here at the second one, so that should never go out. And then I end here. What if I just did 0? Like, I don't think that's a syntax error. No. 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 Uh, Index outside the bounds. Two. So yeah, this does need to be -1 because it's not inclusive. And we start at the second one? Let me just see if that works. Okay, note to myself, I need to go back over Python to figure out, because they always like, oh, is this included? Is it not included? Anyways. Okay. I wasn't expecting that. All 3 test cases passed. Wrong answer. Okay. I know. I said a 95% chance of failure. Yeah. I don't know. I don't know. I have no idea. Okay. What's the answer? What is the answer to this problem? No. Code. Okay. Find the pivot. First decreasing element from the right. So I come here and just find when this condition is true. And then if the pivot is found, swap with the next largest. Okay. So I'm finding and then swapping. Okay. Reverse the elements to the right of the pivot to get the smaller arrangement. Sure. Okay. And then, sure, whatever. Anyways, so that was that problem. Number 31, next permutation. We failed on all three counts. To understand the problem, failed. To try to implement the problem from words, once we got the hint of understanding what the problem was, take it from those words to actual code solution, failed on that. We failed on the third one, which is even once we understand or once we just are given the answer, here's the code. Can you understand it? It's like, no, I don't understand it. So we failed on all three counts. Darn. Okay. Oof. Well, welcome back to Leetcode. I haven't done Leetcode in 3 months. And welcome back. Oh boy. This is my return welcome from Leetcode. Anyways, thank you guys so much for watching this video. My name is Timothy Lee Grant. I hope you guys understood this problem more than I did, but I will be back soon, either tomorrow, maybe the next day, whenever I feel like doing another Leetcode video. So I will be making another Leetcoding video very soon. If that is interesting to you, subscribe to this channel, and we are going to continue moving forward on software engineering and Leetcoding and trying to level up our skills. Anyways, have a wonderful rest of the day. I will see you guys later.